Cellular. We all know what cellular is, right?
Yeah,
So cellular is based on cells, meaning little circles around the cell tower, and theoretically, when you go from one to the next, it's supposed to transfer over. Out here, maybe not so much.
yeah,
Bluetooth is very short communication. Like, if you go out of the room, it's probably gonna cut out. It's not
Right.
very strong. It's designed for local communication.
Yeah.
Does anybody know what NFC is, near field communication?
I almost,
Do you ever do Apple Pay or any of those things with your phone?
oh, that's what it is? Okay.
Yeah. So you have to have it almost right on top of it. And then I've not ever set that up, but some people will use like
Apple Pay.
Apple Pay or like Google, whatever,
Yeah.
you know, and then that, when you do that, that's near field communication.
Okay.
So Bluetooth has energized antennas on each side. Near field communication, the little device has no energy. It gets it from the antenna.
Mhm.
And then it's like RFID tags are the same way. They don't have any energy. The antenna excites it, then it reads it because the antenna sends out enough electromagnetic radiation that it then activates the antenna and you can read it. RFID has more distance. Near field means you about have to have your phone right on top of it. That makes it also more secure because you have to be like really close.
Yeah.
For it to work. All right, so those are some things. We already know about that. Yep, let's keep going here. I love the shows where they're gonna do like they blue jack somebody and they blue jack them from like 10 miles away. What's wrong with that picture?
That's, Bluetooth doesn't go 10.
It doesn't go 10 miles, you know, or wherever. I mean, it barely goes from here to like, 50 feet away maybe. And if you hit a wall, well, it pretty much stops it. You know, I can almost get around most of my house with Bluetooth, but if I went much further, it starts dropping.
Right.
All right, so near field communication, see, 4 centimeters. The devices, oh, I didn't know that. They can be passive or active, but one of them needs to be active to activate the other one.
Right.
Because an NFC device can be read if it doesn't have power, like an NFC tag, which would be like the little contact payment thing on top of some credit card things or whatever they use. But you have to have this one to transmit, to actually activate that guy and transmit data. So that's what you're using. Oh yeah, and also RFID works the same way. So this magnetic field induces a magnetic field in here, and when it hits the wire, it changes into electricity. Because electricity is magnetism, magnetism is electricity. They're different forms of the same stuff. I don't know, it's pretty scientific.
Cousins in the same family, basically.
Yeah, well, I'm not a scientist, but yeah, electricity, when you generate electricity, it generates magnetism around it. And so by putting it in a coil or some other shape, you can shape the magnetic field so it's bigger, because even just any kind of electricity has a certain amount of a magnetic field around it. And by shaping it into an antenna, you can extend it or change it. So when wireless access points like this one does, they use something can be called beamforming, meaning it maps the location of all the devices in the room. And then because it has multiple antennas, it can then balance that to send a strongest signal to all the devices. So it doesn't just broadcast blindly. It tries to target your phone, my phone, whatever is connected up to it. This is blind. This has no targeting. You have to be within a certain range, or this magnetic field cannot induce electricity in this coil to activate the tag. So they call that magnetic induction. The same principle is used if you have a phone charger where you can set your phone on it. The same principle is used there. The little charger is inducing a magnetic field here, which turns to electricity, and that charges your battery. And network wires do the same thing. So if you have something close enough to the network wire, you could read the information coming through the network wire. Would that do you any good in this room? No, because everything's between us and everything we talk to is encrypted. Everything we do on the web is encrypted. Everything between these computers and the domain controller is encrypted. Pretty much everything that we send is encrypted, except for like broadcast ARP packets and a few, necessary things to get things to happen.
Mhm.
All right. Yeah. RFID is very similar. And as you can see, it's the same idea. They can be very small, but they have more of a distance. So RFID tags could be used at Andy's place of work. If all of his stuff had RFID tags and my card had an RFID tag, all I have to do is wheel my cart through, it totals everything up, I'm done. I don't know if that hasn't really caught on yet. Now, what about wireless local area network attacks? Well, what is our current version of Wi-Fi?
7. Oh, wait, you need read?
No, I'm just saying Wi-Fi, we'll say standards. So this is the beginning. This is where I started. G was the next big one. N, we still use N, but it's part of AC. So when you do, this is 2.8, 2.4, this is 5. So a lot of our Wi-Fi has these two together.
Mhm.
And then Wi-Fi 6, which is what we have in the room, the makerspace. This is Wi-Fi 5 because it doesn't have that extra channel that Wi-Fi 6 has. So ours would be at Wi-Fi 5 because we have N for 2.4, and then we have AC for 5 gigahertz. And this is what we have with our little router in the makerspace. And this is an extension, and this is the newest one, which there's not a lot of stuff out. But each time as they go, here's a good one. 802.11n introduced MIMO, multiple input, multiple output. Remember I was saying that there's multiple antennas? Well, each antenna has a different path to Owen's phone. So if these two aren't working right, then we send it by these two. And so by having these combinations of antennas, we can send information and get past bouncing things, or we can make sure we avoid this. So it allows the wireless access point to tune how it's sending its signal. So just blasting everything. And as they've gone on, it gets improved. They've been improving that. Just sending the energy where it needs to go instead of just blasting everybody. Now, Wi-Fi 6E should be able to take people that run Wi-Fi 5 and Wi-Fi 4. But when you have backwards compatibility turned on, if you have one person running slow because of the way you access an access point, everybody runs at that slow speed. It takes everybody down. But you're not going to notice because most of the time the bandwidth limitation that people see is the internet bandwidth limitation. Anyway, these are all 802.11 standards. Wi-Fi is just easier for people to understand. You know, these I recognize because that's what I'm used to seeing. All right, so now we know all about the standards, more or less. And for you to work at Wi-Fi 6, your device have to have Wi-Fi 6 and the router and the wireless access point. You have to have it on both ends. And I don't know, I think most phones are probably at Wi-Fi 5 yet, I don't think any of them are Wi-Fi 6, because that's fairly new.
I haven't, so.
I haven't seen anything like the sales saying, oh, we got Wi-Fi 6.
Yeah, unless they're happy, I heard that. Says, yeah, they-
Yeah,
Yeah, I haven't seen anything with iPhone, yeah.
so the access point, that's only an access point, What do you have at home? You have a router, you have a wireless access point, you have a switch, you have a DHCP server, you have all that stuff in one device. Excuse me?
Have you done that?
Yep, that's the switch part where you have Ethernet. So that's a multi-purpose device for a home office, small office. In a business, you typically have separate devices because you need more capacity. And you need more quality too. So this is only an access point. That's all it does. It can do other things. I just haven't turned them on. You know, it can be a DHCP server. What else can it do? It can, it's just like our little guy there. It can do it doesn't repeat, but it does the whatever that thing is.
Extend?
Not extend, because that's still the same thing. Where the back channel's on a different channel and you're not interfering with yourself. Anyway, I can't remember the name. What was that?
The match.
Yeah, the mesh. This can do a mesh network if we had another router. So the difference between, so when you're at home and you can't get to another part of your house, there's a couple different ways to do that. WFI, you can do an extender versus mesh or booster. Extender, booster, they're the same thing. Ooh, there's a picture. Let's see if that's a good picture. Oops, I did the wrong thing. Open image in new tab. Oh, that's a little donkey picture there, isn't it? Oh, you can't hardly see that. Oh, that's horrible. Let's find a better picture. Yeah, that's not bad. Let's try that one.
Might be that one there,
Which one?
lower corner, like left. Looks the
Down here?
same as one you were looking at, but more detail than all there.
This one actually is better,
Okay,
but none of them really show exactly the right thing. Oops. Yeah, we'll just, that's a. Okay, well, maybe this will work. We'll go to this one. Let's see, open in new tab. Oh no, open image in new tab. So this is not a very good picture either. Anyway, if you have an extender, say this is your wireless access point. If you have an extender, it sends and it broadcasts on the same channel. So you're fighting yourself. So it can help, but it's not the most efficient way. This is what this access point and the one that we have in the BPOD does. You have your access point, it sends information to the mesh sends it back on a different channel. So you're not fighting yourself. And you can have multiple, and just like this, when you go between them, it's supposed to be nice and smooth. Well, this is also supposed to be nice and smooth, but as Owen and I were making experiments, which we ended up actually with a better solution when IT said you couldn't do that. This is much better. If you can do a mesh network, that covers your house a lot better. And most systems now have a mesh network capability. Yeah, Andy,
how would you go about creating a mesh network?
there's just a setting in this one that it just says create mesh network, and then you hook on your little guy. It's all built into the interface.
All you'd have to do from there is, I think you can, if they give it a default for your ranges, because it does split up your network ranges.
So would you just need a bunch of routers or what?
You would have a specific router that you can buy mesh network things with.
Yeah.
So kind of like this. This would be like our extender, our mesh guy that then communicates with our router.
Mhm.
But it's not an extender because it's hauling, because you have to send information here and information has to come back. But if you're sending and receiving information on the same channel, you're fighting yourself. This they call it a backhaul, meaning when you come back is on a separate channel. So it doesn't run into each other. So you would want to buy a router that has mesh network capability. We'll just go to Amazon and take a quick look. Amazon, we'll find ours. Ours is a TP-Link, right?
Yeah.
TP-Link mesh router. There we go. I don't know that any, oh boy, it said don't look anything like ours. Ours kind of like that, except that's not newer. Well, we'll just say this. So if you bought, we'll just go to this one. So one of these is going to be the main guy, right?
Mhm.
And, oh, it also can do a wired backhaul, which that's better. Huh. Anyway, I don't know where ours is. Anyway, it's like this. And then you can buy extra pieces that automatically connect with it. The mesh usually works best if you stick with the same manufacturer and the ones that are actually supposed to be with it. So let's look at, I think ours is newer than this. Well, this is probably ours right here. Oh, that's actually it. Maybe. Oh, close enough.
Yeah.
So it does beamforming, it does long range coverage. It has one mesh, which is TP-Link's version of how you connect things together. And then you can get like a little, where's the little guys? I don't see one. We have like a little thing you plug into the wall. Basically, you plug it into a wall jack. And then that becomes the extension of the network. Like this, except ours doesn't have antennas. But it's just a thing you plug in the wall. Once you configure, you can plug it in wherever you want. And it talks to this guy. He sends the information, this sends information back, because network communication is a two-way street. And mesh networks work pretty good. This is not the one we have, it's not that expensive. Because this is Wi-Fi 7, we have a Wi-Fi 6 and it has one that's just like it. I just don't see it here, but it's basically the same thing. You plug this into the wall, it's not a router, it's just an access point that is connected to here. So that works. All right, where are we at here? Moving on. Oh, a typical WLAN, yeah. Well, you don't have a file server at home, but same kind of stuff. That's not new. Oh, did you know there's thin and fat APs? So this is a fat AP, meaning it does everything. It's the controller, it does the encryption, authentication, all of that. What we have at WNCC is downstairs, we have a couple switch looking devices that all the access points are connected to. So the access points are almost literally just antennas. They carry the signal back to this main controller, which does all the authentication and handling of everything. So it allows you to manage all the access points from one location. This also has that capability. So from that access point, if I had 20 of those, I can manage it from that access point. So it has similar capabilities, but not quite as enterprise as Cisco. We all know what a captive portal isn't it? It's a good way to have everybody not use our internet anymore. Right? Internet Plus? Yeah, they said they've done some updates and it's working better, but I'm guessing by now everybody gave up and they're just using their data plan and everything else, right?
Here's Wild West here.
Yeah, I pretty much, that's all I do is go from here to there, so, I may use my data plan here and there, but I really don't do much else except these two rooms. So how do you attack a network? If I can sit in the parking lot and get a signal from your Wi-Fi, I can just sit there and take all my time I want. If I can sit across the street and do the same thing, I can take all the time I want to crack your WPA2 encryption or whatever you've got, right? So, what we had before, they call it a hard edge, meaning when your Ethernet cable stops, that's it. Nobody can get to it. It doesn't go outside the wall. Well, wireless goes outside the walls. Except Mike can tune that with Cisco. So he can tune it so it doesn't go outside the walls. I can't do that with that, I don't think. That's not that sophisticated, but this is pretty sophisticated, but it doesn't do that. So if I can sit in the parking lot, I have all my time in the world to do things. Well, we've done this. I brought in my little thing one day and we did an evil twin, right? So could Mike recognize that? Yes, the Cisco wireless has capability in it to recognize if somebody's faking that they're actually the wrong thing. So it's more sophisticated than that guy. I don't know, maybe that guy has that in, I just never looked it up. So if I hadn't talked to IT about this, which I have, and they actually gave me this wireless access point, I would have a rogue access point. Or they also call it, what's the
Shadow
name?
IT.
Shadow IT, meaning you do your own solutions because IT is not gonna help you. Evil Twin, we did that the other day. I set my little device up for internet AP or free Wi-Fi, and then I can get all your stuff.
Mhm.
So jamming. We can do a denial of service. I could set that little device I had, so it sends so many connection attempts to that wireless access point that it can't actually do anything with anybody else. So that's like a denial of service. Or I can do RF interference. So one of the things that's changed, and this is true, most home users do not configure any security because it's not convenient. If security is not convenient, people won't do it. If they don't know how to do it, they don't know do it. And how many people at home know how to do any of that stuff or understand any of it? Nobody. So what has happened that has changed that in the last 2 or 3 years? What's changed so that this is not as much of an issue anymore? When you got your internet access from whatever provider you got, was your wireless wide open?
They
That's
figured
what-
it themselves.
Yeah, that's what's changed. When you buy a new access point, when you get something from Charter or whoever, Allo, it already has encryption turned on. And they usually stick the code or the key right on the device. So you have to be physically there to get it. So that is one of the things that's changed. The industry has decided, well, we don't need any of these open things because nobody sets them up anyway. Let's set them up ahead of time. Like wireless access points will have like the little code right on the access point when you buy them. WEP is ancient. We don't care because nobody should use it. WPS is a bad thing because the flaw is a PIN can be just a 4-character number. And how long would it take to go through and brute force attack a PIN?
Not really.
4 characters. Yeah, not very long.
With a
So if you have WPS turned on your router, turn it off.
16 character combination of numbers,
But,
numbers 16,
well, 4 times
9.
4 times 4 times 4 times 4 would be the combinations, because you have 1 through 9. Yeah, I don't think that's right, but it's more than
I think it's 4 times
that.
4 times.
Yeah, because you have 1, 2, you have 1, 1, 1, 1, you have 0, 0, 0, 0.
Oh, then 10 even,
Yeah,
so
this,
there's like
there's,
160, that's not a lot though.
no, you can ram through that pretty quick.
Mhm.
So turn it off. If you have your own access point, turn that off. In fact, now it's almost always turned off on newer routers because nobody uses it. It was a convenience thing, but again, convenience does not equal security necessarily. But if you have it, turn it off. Here is one that Mike uses to make sure that if I take my computer from one office to another, it won't work. So he has it set up in the switches that it'll only recognize the MAC address of the device that's supposed to be connected to it. In this room, I have nothing like that. I don't have that turned on. Anybody can plug anything in. But in Mike's case, if I move my computer or I plug in my laptop, it won't do anything. So it permits or blocks based on the MAC address, and you can do that with the wireless access point. The problem is this. If you have a large number of addresses, it's really challenging to manage that. There are automated ways to do that, and that's one of the things IT is working on. There's a product called ICE, which I don't know what it stands for. It'd be a good time to look it up, that Cisco does. It's kind of a big, giant security platform. Let's see what ICE is. Cisco Identity Services Engine. This is what they're looking at turning on, which interestingly enough, if we had this, we wouldn't have to. We could have our devices hang on for more than 1 day and it would be a lot better solution for our wireless than we have right now. So I'm thinking, why didn't we just do this in the first place? I don't know. If we're gonna replace it with something. But that's what that does. You can't connect unless it says you can. Zero trust means you have to prove who you are before you do anything. Here, you can do anything and you don't have to prove who you are. So zero trust is one of the new paradigms, meaning thoughts, ways to do things in cybersecurity. Don't trust anything until you've proven that you can be trusted. That's what zero trust means. And that's something you'll see people advertising. Yep, so you can manually put in a block, you can allow stations, you can block stations. The problem is going here and manually doing this, that would be a pain in the Watusi. So there's other better ways to do that. WPA is also old. WPA2 is our current standard that we use. WPA3 is coming out. We have 2 types. We have WPA personal, WPA2 enterprise. Which one do we use in this room?
Enterprise. Probably. Really? Use personal?
Do you have to log in with your username and password?
Oh, no, you're right. No,
Yeah.
you're right.
So enterprise means that you're using a username and password to authenticate to the access point. And every time you authenticate, you're getting a different key. So the shared key is never the same
Okay.
because it's based on your hash of your login. So personal is what everybody has at home. You have a shared key that everybody knows. So it does encryption, it does authentication. Is there any authentication with a shared key in the personal? No. Anybody that has a shared key is in. With encryption, yes, and with enterprise, you have both. You have encryption and you have, Owen has to know his password to connect or whatever it is
Yeah.
that you have to have. But then that's kind of what you would call pass-through authentication. When you sign into your laptop, that should also authenticate your wireless connection too at the same time. In an ideal world, but not in a guest network like we have. That's something you do in a business network. Like if we implemented Wi-Fi for the business people and they had laptops, then when they log into the server, that should then authenticate them to the wireless at the same time. And you can do the same thing with wired ports. You can't do anything unless you authenticate to it, and it's a valid authentication. Is that easier to manage than port MAC addresses on ports? Oh, yeah. Yeah. All you have to do is maintain your Active Directory.
Oh, you're right.
Otherwise, I have to go through and with each port, I've got to put, okay, there's Owen's MAC address, there's this MAC address, there's that MAC address. Yeah, no, thank you.
Yeah.
Then you have, not single factor authentication, but single sign-on authentication. Okay. Moving on, we don't need to, oh, there's the new one. So where you can capture the hash is when the wireless access point first authenticates. Well, here it is at the handshake. They have it so that each of them do it at the same time. So that interval of being able to capture the hash is a lot slower. I mean, it's a lot less. Oh, okay. So a site survey, that's what we're going to do. We're gonna do a site survey. What kind of phone do you have, Andy? Android, iPhone?
Android, I think.
Okay, then you have everything you need. Yep, that pretty much takes care of that. We are going to do a site survey.
I don't have it on me though.
Uh-oh. Failed the class in.